This is Molly. Molly was surrounded by a lot of sick people at school, but she managed not to get sick. The question is, how was Molly protected?
Damn, it feels good to be a gangster.
Easy. Her immune system protected her from the evilness. The immune system protects your body from any harmful organism, which are all categorized as pathogens. Your body has a whole army made up of different types of cells to protect you from any pathogen, because you are the most precious thing to all the living cells in your body. So hey, if you're ever feeling down, just remember that your body is always out there to protect you, because you are loved. Your body's first measure of defense starts on the skin, which is a super tough barrier, because your body needs to prevent these pathogens from entering the body and harming you in any way. So your skin needs to have specific properties. It has a dry and thick outermost region called the epidermis, which is mainly made of dead surface cells, so pathogens aren't able to infect any living part of you just yet. It also contains sebaceous glands that secrete acidic chemicals like lactic acid and fatty acids to inhibit microbial growth. It doesn't end there though. Your body has mucous membranes for internal structures accessible to pathogens, such as the trachea, which brings air to the lungs, and the nasal passage, which brings air into the nose. Here, unlike the epidermis, living cells actually exist. But they're not just there though. They secrete special fluids that include lysosome, which is an enzyme to wash away and destroy pathogens. So to be honest, pathogens really stand no chance against the body. But what if they're the Chuck Norris of pathogens and can still enter the bloodstream? This calls for a special type of cell called leukocytes, widely known as white blood cells. There are many types of leukocytes in the body. One very important leukocyte is the macrophage. Macrophages are present in the bloodstream, where they recognize potential harm by examining the proteins on a cell's surface. If the proteins encountered are deemed as local to the body, they are labeled as self, and the cell is left alone, just like this red blood cell. But if it's deemed as foreign to the body, the macrophage labels the cell as non-self, and the cell becomes lunch for the macrophage through a process called phagocytosis. Delicious, huh? This is called non-specific immunity, because macrophages eliminate any potentially harmful cell without any specific identification. On the other hand, specific immunity is when the body actually cares about what's attempting to break in. Lymphocytes are also another important leukocyte. All pathogens have a tag called an antigen, which is made up of proteins and lies on the outermost layer of a pathogen to help the body recognize it. Its presence triggers the naive B lymphocytes to become specific B lymphocytes and produce antibodies to eradicate the pathogens. Oh, and they also clone themselves to increase the production of antibodies.
But how do antibodies work?
Easy. They bind to their designated antigen and then destroy the pathogen. Like this rotavirus here, who's gonna die soon because of the antibodies. But what if more show up in the future? Well, memory B lymphocytes or memory B cells remain in the bloodstream. So, the next time the sibling shows up to avenge brother Rota's death, the body's well prepared. And that is how Molly survived.